Today, we're going to dive into a really powerful tool that helps pretty much everyone, from big companies to the military, make the best possible choice when you can't have it all. It's called linear programming. I mean, this is the classic problem, right? You've got limited time, a tight budget, maybe not enough space, and you want to squeeze the most value out of whatever you've got. Well, that's called optimization, and it's something we all do. And today, we're going to learn a surprisingly simple way to get it right. So to get our heads around how this all works, let's follow a story. We're going to look at a furniture dealer who's facing a classic business problem. How do you make the most profit when you've only got so much cash and a small storeroom? Okay, so here are the numbers our dealer is working with. They have a total budget of 50,000 rupees. Now, each table costs 2,500 and makes a 250 rupee profit. Chairs are way cheaper, only 500, and bring in 75 rupees of profit. But here's the other big catch. The storeroom can only hold 60 total pieces. That's tables plus chairs. So, what's the best move? Well, your first instinct might be to just go all in on one thing, right? If the dealer only buys tables, that 50,000 rupee budget gets them 20 tables. The profit? 5,000 rupees. Not bad. Or what if they only buy chairs? They'd hit that 60-piece storage limit pretty fast, and the profit would be 4,500. So these are okay starts, but the real question is there a mix of tables and chairs that can make even more money? To find that perfect mix, just guessing isn't going to cut it. We need a system. And the very first step is to take this real-world problem and translate it into the clear, simple language of mathematics. First up, we need to name the things we can actually control. We call these our decision variables. So let's just say X is going to be the number of tables we buy, and Y will be the number of chairs. Easy enough. These are the two levers we can pull. Next, we have to define the rules of the game, our constraints. First is the money, 2,500 for each table, so 2,500x, plus 500 for each chair, 500y, has to be less than or equal to our 50,000 rupee budget. Then there's the storage space. The number of tables, x, plus the number of chairs, y, has to be less than or equal to 60. These two rules create the boundaries of our problem. And finally, what's the whole point of this? The goal. We want to make as much profit as possible. We call this the objective function. The total profit, let's call it Z, is going to be 250 rupees for every table, plus 75 for every chair. Our whole mission is to make Z as big as it can possibly be. Now that we've turned our problem into these neat little equations, we can do something really cool. We can actually draw a map of every single possible choice the dealer could make. So here's how it works. You take those two rules, the one for the budget and the one for storage, and you draw them as lines on a graph. The x-axis is for tables, and the y-axis is for chairs. The magic here isn't really the lines themselves, it's the area where everything overlaps, the spot that follows both rules at the same time. And what you get is this shaded area, our map of what's possible. It's called the feasible region. Literally every single point inside this shape is a combination of tables and chairs that the dealer can afford and has room to store. So, buying 5 tables and 20 chairs, that's a point inside this region. But buying 30 tables and 40 chairs, nope. That's outside the map. It's an impossible plan. Okay, this map is great and all, but it creates a new problem. There are technically an infinite number of points inside this region. How on earth are we supposed to check every single one to find the absolute best profit? We can't just poke around and guess. And that's because, and this is the really cool part, there's a secret. There's a beautiful, elegant shortcut that makes solving these problems way easier than you'd think. It's all about the corners. So here's the absolute key to this whole thing. There's a rule in math, the fundamental theorem of linear programming, and it says that the best possible answer, our maximum profit, will always be found at one of the corners of our feasible region. This is a total game changer. We don't have to check a million points inside the map. We just have to check the handful of corners. So these are the only 4 spots that matter. We've got the starting point, O, which is 0, 0, basically buying nothing. Then point A at 20, 0, that's our all tables plan. Point C at 0, 60 is the all chairs plan. And then there's point B, the interesting one, where our 2 lines cross, which represents a very specific mix, 10 tables and 50 chairs. All right, this is it, the home stretch. All that work of translating and mapping has boiled down to one very simple task. Let's just plug these 4 corner points into our profit formula and see which one comes out on top. Let's run the numbers. At 0, 0, obviously the profit is 0. At 20, 0, the all tables plan, we get 5,000 rupees. At 0, 60, our all chairs plan, it's 4,500. But now, look at point B, the mix of 10 tables and 50 chairs. You run that calculation, and you get a total profit of 6,250 rupees. And there it is, 6,250 rupees. That's the highest number on the list. That is our maximum possible profit. We found it. And just like that, we have the answer. The single best, most profitable strategy for our dealer is to buy 10 tables and 50 chairs. This perfectly uses all 60 spots in the storeroom, stays within budget, and delivers the absolute maximum profit they can make. And this isn't just a neat trick for a furniture dealer. This whole idea blew up during World War II for figuring out military logistics, getting the right supplies to the right places with the least cost and effort. It's been used to design the most cost-effective diet plans, and the guys who developed it even won a Nobel Prize. It's a powerful tool that quietly helps run the modern world. So that kind of leaves us with one last thought. Whether it's how you manage your study time to get the best grades, or plan your workouts to hit a fitness goal with the little time you have, we all have these optimization problems. So what's a puzzle in your own life that now you could actually map out?